This is going to be a video on Chapter 6.2, Advanced Derivative Rules. First, we need to go through all of the advanced derivative rules so that we know them and can apply them then on different problems. So first we have the chain rule, and in your formula booklets it looks like this right here. Now you'll know to use the chain rule whenever you see it set up such as this, so you have a function of another function. If you have this set up, then you will use this formula, which is w prime times u of x times u prime of x. This is how you will get this is how you use the chain rule. This is the formula. We'll go through practice problems later. So next up we have the product rule, and the product rule will be used whenever there is multiplication. So here you have h of x equals f of x times g of x. Since this is being multiplied, you need to use the product rule. Right here is the equation for the product rule. So you will have that h prime of x equals f prime of x times g of x plus g prime of x times f of x. So you will use this formula whenever you have multiplication. So here is our third rule, which is the quotient rule. It is used for division. So whenever you see division, like here, y equals u over v, this is where you would use the quotient rule. And right here is the formula for it. So y prime equals v times u prime minus v prime times u over v squared. So use this formula whenever you see division. You can plug in your v and u values, remembering that u is on top in the numerator and v is the denominator, and you will have a quotient rule. So now we're going to move on to some example problems of the different derivative rules. Our first rule being chain rule. So here we have a problem, f of x equals 6x squared plus 7x all to the fourth. This is a problem that requires chain rule. Here I wrote out the chain rule formula, remembering that we need to find w prime, u prime, and u. And if we shift down, I filled in each of those. So for w prime, you'd have to multiply it times 4 and subtract 1 from the exponent, which gives us our 4 in front, 3 in the exponent, keeping the same in here because u is not prime, it's just a regular u, times u prime, and u prime is 2 times 6, which is 12, subtracting 1 from the exponent, which is just 1, so 12x right here. And then right here, it's like a 1 in our exponent, even though we don't write it in, but there is a 1 there. So we multiply that times 7, which is 7 minus 1 is 0, so the x goes away. So then we have this, which is not our completed chain rule. Then we have f prime of x equals 4 times 12x plus 7 times 6x squared plus 7x to the third. This is our finished chain rule. Our next example rule is going to be product rule. So product rule, remember, is when we have multiplication. So here h of x equals 6x cubed times 7x to the fourth. So since these are being multiplied, we use product rule, which is written out right here. We have to remember that we use f prime of x times g of x plus g prime of x times f of x. So using this formula and these numbers, we get that f prime of x equals 8x squared, g of x just equals the 7x to the fourth, g prime of x equals 28x to the third, because 4 times 7 is 28, subtract 1 from the exponent gives us 3, and then just f of x, which is 6x to the third. Now, if we have to simplify this a little more, you can multiply these to get 126x to the sixth plus 168x to the sixth if you multiply these. And then adding these two together to simplify even further, we get h prime of x equals 294x to the sixth. So if you were following along with the math, that should be the answer you got for the product rule. For the next example, we have quotient rule. So quotient rule is used for division. So here we have g of x equals 6x squared over 2 minus x. This is using division, so we use quotient rule. If you have that written in your notes, great, or else it is written right here. remember v times u prime minus v prime times u all over v squared. If you follow this formula and plug in your numbers, you will have 2 minus x for v times 12x for u prime, because 2 times 6 is 12, minus 1 in the exponent is just 1, which you don't have to write in, minus 6x squared to the negative, well, times negative 1, because v prime is negative 1, because negative x is just imaginary. We can't see it because we don't write it in, but 1 here times negative 1 is just negative 1. Minus 1 is 0, which gets rid of the x, you have negative 1. All over v squared, so 2 minus x squared. That can be simplified even more, or written out even more, to 24x minus 12x squared plus 6x squared all over x squared minus 4x plus 4. And that can even be written out more. You can take these two, negative 12x squared plus 6x squared, and you can add them together to give you negative 6x squared. And this equals g prime of x. So 24x minus 6x squared over x squared minus 4x plus 4 equals g prime of x for this quotient rule example. The next thing we need to know is the equation of the normal line. So we're going to start by using an example to go through it. Makes it easier to understand. So here we have f of x equals square root of x squared plus 3. And we're going to evaluate this at the point negative 1, 2. So the first step is to find the derivative. So we're going to have fx equals square root of x. Well, we're going to move the square root to be a power so that we can handle it better. And that would be to the 1/2. F prime of x equals 1/2 x squared plus 3 to the negative 1/2 times 2x. Now, this step here, we used one of the 3 rules we already learned. Here we use chain rule because it is a function within a function. So to do that, we multiplied the exponent into the front, which gave us 1/2 here, and subtracted 1, which gave us negative 1/2 in the exponent. And then we multiplied times the derivative of this, so x squared would be 2 times 1, which is 2, minus 1 is 1, so just 2x, and 3 just goes away. So then you have this, and writing that out, you get f prime of x equals x over square root of x squared plus 3. Because once you multiply by 2x, you have 2x over 2, which leaves you with just x. And this negative 1/2 up here puts the square root into the denominator because it's negative and it's half. So you get that in the denominator. So there is your derivative for step 1 of finding the normal. So once we have our derivative, step 2 is to plug the x-coordinate of the point we were given into the derivative. So f prime of negative 1 equals, plugging in negative 1 for our x's, negative 1 over square root of negative 1 squared plus 3. This equals negative 1/2. Now, that is the slope for the derivative, but the slope for the normal line is the opposite reciprocal. So the opposite reciprocal of negative 1/2 is 2. So the slope for our normal line is going to be 2. So that was step 2. For step 3, now you need to plug all of the values you got into the equation. So here we have y minus y1 equals a times x minus x1. This is the equation. We just have to plug in the values. So y minus, the y coordinate is 2. Our slope, we said, for the normal line was 2. And our x coordinate is negative 1. So we're going to end up adding 1. So y minus 2 equals 2 times x plus 1. Now we can simplify that a little more. We get y equals 2x plus 2 That's on this side, 2 times x times 2 times 1, so 2x plus 2. And then if we add the 2 from over here, plus another 2, which gives us plus 4. So the equation of the normal line is y equals 2x plus 4. So next up we have some practice problems that we will go through together. So here I have written down some values that you will need. So f of 3 equals 2, f prime of 3 equals negative 1. Write these down in your notes or wherever you're writing stuff down, and keep those because we will use them for the next 2 questions. So using the values that you just wrote down, find s prime of 3 if s of x equals f of x over g of x. So the first thing we need to do is figure out which derivative rule we will be using. And since we can see that f of x over g of x is division, we're going to use the quotient rule. Look back in your notes for the formula for that. Using the quotient rule formula, we can see that s prime of x equals g of x times f prime of x minus g prime of x times f of x all over g of x squared. So now, since we need s prime of 3, we're going to plug in 3 for x. So here it is written out. We have all of our 3's in for our x's, and now we're going to actually put the values in for that. So that's why we wrote down the values from before, because g of 3 is one of those, f prime of 3 is one of those values. So you're going to look at those values and write them down here. So I have written them down: 4, negative 1, 0, 2, all over 4 squared. So if you do the math for this, 4 times negative 1 is 4, minus, 0 times 2 is 0. All over 4 squared is 16. And then the final answer for s prime of 3 equals negative 1/4. So this is the second and final question that we'll be using the values that we wrote down. So find t prime of 0 if t of x equals f of g of x. So seeing that we have a function of another function, we're going to be using chain rule. So look back in your notes for the chain rule formula. Here I wrote it out in the format that we will be using. So t prime of x equals f prime of g of x times g prime of x. And then I filled in the values because we're looking for t prime of 0. So I put in 0 for x. In doing so, using the values that you already wrote down, you'll find that g prime of 0 is 0, g of 0 is 3, and then f prime of 3 is negative 1. But since you multiply them and this one was already 0, it doesn't really matter because anything times 0 is going to be 0. So our final answer is t prime of 0 equals 0. So this is a practice problem that you're going to try on your own. So for this one, you need to find the equation of the normal line for this function at the point 1, 5. So pause the video here, solve this. You can use your notes, look back at the example we did, and then resume the video when you would like to see the answer and how it's done. So here's the answer in this kind of oddly shaped box. This is the equation of the normal line. So you start with finding the derivative, which is done right here. Now the slope of the derivative is negative 6, opposite reciprocal, 1/6 for the derivative of the normal line. And then right here, this is the step of plugging it into the equation and then simplifying that equation for the normal line. For the second problem, you're going to try on your own. It is a 2-step question. So when I go over the answers, I will first go over A and then go over B. Using this function, k of x equals x squared times sine of x, find k prime of x and find k prime of 3. So go ahead, pause the video right here, write this down in your notes, solve it, check back with your different derivative rules and the notes you already took, and then resume the video to see the answer and the work. So here's the answer for letter A. Using the product rule, because it was multiplication, So you have to find f of x, f prime of x, g of x, and g prime of x. So I wrote those out. And then plugging those into the formula in the proper place, you get 2x sine of x plus x squared times cosine of x. That is k prime of x. So here's the answer and the work for B. So you start, well, to find k of 3, you need to write out, I just wrote out the equation we had, and then plug 3 in for x, and that will give you 0.847 plus negative 8.91, which if you add those, you get k prime of 3 equals negative 8.06. That is the problem for the second practice problem. Check your work, write it in your notes. Alright, thank you so much for watching, following along, doing the problems in your notes, and I hope you learned something about advanced derivative rules from chapter 6.2.